Hello fellow programmers and welcome to the 10th video in the C# tutorial series. So the last video we went over enums, and if we're going to brush over them a little bit more with arrays and combination of the two. So if you haven't seen that video and you're not too familiar with arrays, or you just want to know why I have a whole bunch of card values here, be sure to check out the last video, and that'll get you up to speed with this current video. Okay. So arrays. Now arrays in C# really don't differ too much in arrays in many other languages. An array in C# is a data structure that holds a fixed amount of elements of whatever type that we give it, okay? And the key word there is fixed, and we're going to learn pretty soon why it's fixed and the benefits of it being fixed, and then of course the benefits of it not being fixed, which is a little self-explanatory, but we'll see why here in a second. So let's first look at how to declare an array, okay? And first we give it an access level, which we'll give it public. And then we'll have an array, which is denoted by a left and a right bracket. An array that holds integer types, the name of the array, which we'll call test array, okay? Now that's pretty much the simplest way to do it. However, at some point in time, we're gonna have to actually allocate memory for this test array. And most of the time it's done right away. But of course it doesn't have to be. So let's first make it static, just because of the fact that the main is static. So in order to use it, we need to make this static. Now we'll do it right away. We'll do new, and then we'll do int, just like that. And notice that we're going to get a little bit of an error, and it's because of the fact that we haven't given it a value. That too, but we haven't given it a value of inside of these brackets of how much memory to allocate, okay? And memory, the way that it works inside of for arrays is that it's a contiguous amount of memory given to this particular array. So if we do 10, then it's gonna make enough memory for 10 elements, for 10 integer elements, and it's gonna be contiguous, meaning that each 10 elements are going to be side by side. So you're going to have the first, the second, the third, the fourth, and then so on all the way to 10, right side by side of each other in memory. Okay. Now there's a con and there's a pro to this. The pro is that the read time is very fast and very efficient for arrays because of the fact that the OS gives it a contiguous amount of memory that it's right next to each other. Okay. So it can guarantee that anything for test array is going to be right there by each other. So when you do test array, say, we want to get a particular value for test array, which the arrays in C# are 0 indexed. So this will be the first element, and this will be the second, the third, the fourth, and so on. So if you want the third element inside of this test array, then here's how to get it. And the OS now can determine where it's going to be, and then it's going to be very quick when we want the second value. Something like, test array 3, because of the fact that it's going to be right next to each other. These two objects are right next to each other in memory. And that's going to give us a really fast read time for an array. All right. Now we'll go over the con of it being a fixed size, to be side by side, because it's going to be really fixed. And that can be self-explanatory, of course, but we'll go over that a little bit here in a second. So let's see, that's how to read an array, of course, is how to get its value, right? Now notice that we've instantiated, we've actually created memory on the heap for an array of size 10. However, its elements we never gave them anything. We never gave them each a value. Now let's go ahead and print this out and see what happens, okay? Go ahead and write this first, of course. So we'll do toString, and then we'll do the console read line just to give us a chance to see what's going on. Now notice what happens. We get a value of 0 passed in. So what happens is that the default value of an integer kicks in. And remember when we went over primitive types here a few videos ago, if we have int x, and we actually print that out, that's going to print out 0 because of the fact that 0 is a default value for a value type, and a value type is an integer. So there you have it for that. Okay, so whatever the array follows the same values of the type that it's using. So integers, since they're not declared, they're all going to be padded. They're all going to have 0. So 10 integers of 0 value if we just don't touch it. Now, what about classes, or we should say reference types, which a class is a reference type. And reference types have actually a value of null by default. Now, I know we haven't got over classes yet, but let's just make a simple class and see what happens, okay? We won't do anything inside of this class, of course. But here is a class, okay? Now let's instantiate a new value. I'm sorry, let's make this array that has 10 objects of test program type, okay? Now, when we get this, we'll get the third index, the third test program, and then we'll actually take the value and then we'll toString it. And notice that we're actually going to get an error here when we run it, whereas last time we didn't get an error, we just got the 0. Notice that it says object reference not set to an instance of an object. All right. And what happened is we tried to actually execute a method toString on the value, which is null, was null in this case. All right. Let's go ahead and step through it for a second and see what happens. So here it broke right here. Now if we step through it, we can see that down here the value is still null. Now that's not good, because as soon as we do toString on a value null, that's where we get the error. There it is right there. Now, so just keep that in mind when we're using reference types or value types, that the same rules apply when you ever use them in an array, because it's just not going to work, you know. Now if we go through and make a new value for each one, so we can do something like use a for loop, because a for loop is actually very common to be used for an array of initialization or reading. So if we do int I equals 0, while I is less than test array dot length, C# has a handy method called, or property, length, which gives you the value, okay, which in this case is going to be 10. And then we can do something like I++. Now it'll iterate through 10 times 0 to 9, because as soon as it hits 10, it's going to break. All right. And then it's going to do, what if we did something like actually test array we'll actually do test program equals new test program. So we're actually allocating memory on the heap for this. And then we can do something like test array I, okay, so whatever iteration the loop is in, equals program. Now what happens when we come over here, we can do something like what we had before, value equals test array, and then we'll do 2 again. Now what's going to happen is when we step through this code, nothing's going to be wrong with it, because the fact that it's not going to print anything out, of course, because of the fact that we're not really doing anything with this class, but it's still going to have memory. All right, so let's go ahead and step through this again. All right, so here it is. Now at this point, the array has gone through 10 times and allocated memory for each element inside of its array, its children, if you will. Now, if you can see, value is null at this point, and as soon as it gets initialized for test array 2, we'll see that value right here has a value. Okay, so it has something is inside of it. All right. So now if we do console.writeLine toString, continue, it basically prints this out. Okay, which is just like the default thing for the namespace of where it lives inside of the program. So enums is the project name, .program, test program, and all that is the namespace, enums, program, test program. But it gets the point across that actually it's something, okay? So that's how to iterate, and that's how to basically read from a common way to do it inside of the test program. Now, what about if we wanted to actually not do it here, but to not give it a value, a fixed amount, but to actually start giving it values as soon as we initialize it? You know, we don't want to use a loop or something. And the way we can do that is by the curly braces. We can do something like 4, 3, 2, 55, 44, 88, and there you have it. So right now what we did was you just gave it 6 values. So C# will infer that it's going to be of size 6, and it's going to allocate enough memory for that. And then 0, 1, 2, 3, 4, 5, and so on are going to be the indexes for 4, 3, 2, 55, and all that, okay? So let's go ahead and let's get rid of the code inside this for loop. Let's make this an integer since it's actually going to return integer values now. And then what we can do is actually just print out to the line each one. All right, we'll do test array, and we'll do I, and we can do toString. Let's get rid of this code, get rid of this class since we don't need it anymore. Hit F5. All right, and there you go. There 88 are 4, 3, 2, 55, 44, and 88. And you can just as easily go backwards from 88, 44, 55 just by altering the for loop. So you can do test array dot length -1, and then while I is greater than or equal to 0, since we want to include 0, and then we'll do minus minus so that it decrements. All right. And what this is going to do is just print out the iterate through the array backwards. All right, guys. Now, what if we actually do something like console, or so we can see, we actually would do int value equals test array, but what if we go out of bounds? Like what if we do, this is an element of type 0, 1, 6, so if we, it has 6 elements, so the last index that we can actually access is 5. That'll give us the 6th element, right? Well, what if we do something like 9? That's obviously out of bounds. There is no 9th element inside of test array right now. But notice that we don't get any kind of error, all right? It'll actually let us compile it. So the compiler it doesn't know yet that that's actually going to be an out of range exception, all right? But at runtime, what C# will do for us is throw an exception, all right? So let's go ahead and run this and see what happens. So index out of range exception was unhandled. So the program did crash, but notice that it was actually thrown an exception for us to handle. So what can happen, guys, is C# doesn't crash the program. It doesn't actually just crash on itself. What it does is it throws an exception, and if it's unhandled, it will crash. But if we actually handle it as a programmer with a try catch, and we catch the exception, we can handle it there, okay? Now, obviously, to be careful as programmers, we just don't want to do that at all. We can use stuff like test_array.length and stuff like that to make sure that we don't ever go out of bounds. However, we can do something like a try catch to make sure that we don't ever do anything, okay? Now, we're not going to go over try catches right now because that's going to be beyond the scope of this tutorial. This is arrays, of course, but I just wanted to make sure that you guys knew that C# does handle it and does help you out a little bit. And all it does, it throws something, and then you can catch it and then handle the error there. All right, guys? So now going back to our card example, this makes it really easy on us because now what we can do is we can have an array of cards type, right? Change that here. That's going to give us some errors there. And we can actually have an array that holds nothing but cards enums, all right? So the enum of cards, therefore we can do something like cards 2, cards 3, cards 4, cards 5, and so on. So you get the point. So that what we could do is we actually can have an array. We can just call this deck of cards, and we can have all 52 cards right here. Now, this is really nice because of the fact that because we have this map to the actual values like we did in the last video of the actual values that would be used inside of the game of blackjack. What we can actually do, just get rid of this code right here. If we wanted the value, say cards 2, say if we were to draw a random card, which is what happens really when you draw a card, say we'll do cards, because it's going to pass us back a card, we'll do random card equals, and then we'll do deck of cards, and then we'll get an instance or a card, okay? And then of course the value can be random, like we can do from a random value of 0. So we can do like, remember we did random before in a few videos before, equals new random, and then we can do ran dot next from 0 to 52. And what that will do will give us a value from 0 to 51, which is exactly what we want, because we're going to have to say we had 52 cards in here, we want values from 0 to 51. Of course we don't. We only have 4 values here, so let's just keep it at 3 say. So we'll have 0, 1, 2, and 3. And that'll return us a card, a random card, if you will. And then we can just go ahead and print that out to the line just to see which card was pulled. And the 2 card was pulled. Where next time the 2 card was pulled again. And this time the 3 card. So, there's not really many options in here right now, but you can see that now the 3 card is pulled. And then so on the 4th, the 5 card. So we can see now we can easily be able to depict what card is pulled and then handle that accordingly. And we can do that in a cleaned way with combining our enums in our array to represent a deck of cards. And then we can have, we would easily be able to do like a string, which many people have done before, which would be totally acceptable. Something like this. And then we can do like 2, 3, 4, 5 would be something of the equivalent. And then we can actually just imprint it there. But what's nice about using the cards enum is the fact that not only when we actually get it nice and printed out to the console, well, we can actually use its underlining value to actually get the value of the card that is used in the game of blackjack. Remember that the face cards are worth 10, aces 11, or 1. So what we can do is random card is 2, but then we can also do something like plus, and then we can do value is, and then we can actually cast this to its underlining value, which is the value of this right here. What we'll need to do is we'll do actually value equals random card, and then we'll cast that. That way we can just do a 2 string on this. Be a lot cleaner. All right. Now, say if we had nothing but face cards, just to make it a little more obvious, we'll do 10 cards, jack. And then of course there's going to be 4 of each. In a normal card there will be 4 of each type of card. And remember that the suits do not matter inside of the game of blackjack. We'll do king, and then we'll even throw the ace in there. So the king, the value is 10. So if we go ahead and run it, we'll get king value is 10. And what's going to happen is, because this value is 10, 10, and 10 for the king, queen, jack, and then 10 as well cards, what's going to happen is it's always going to print out random card 10. For any of the 10 values, it's going to print out king, because of the fact that these are all the same value. So what we'll have to do is we'll have to check to see, like, we can do something like if random card equals cards dot, if it actually equals, because we know it, there's many values that can be the 10 value. What we can do is something like random card equals 10, and then we can check the appropriate one. So we'll do like if random card equals cards dot king, then do this stuff. Otherwise, if random card equals something like the joker or the jack, which is also a 10, then do this. So if you want to actually differentiate, you'll have to do a little work to get to that point. Now, just kind of a heads up there. Now, that's pretty much it for that. So I mean, if you want to actually use the enums for the cards and stuff like that, that'll be fine. But if you want to use the string value, that'll also work. So there's many different ways to do it. This is simply just one. And I hope you find this helpful and feel a little more comfortable with arrays now. So when you're using arrays, just remember you want to use arrays when you want to actually speed up your access time, when you're actually reading the arrays, because it's in contiguous memory. And if you want something that's not fixed size, then you don't want arrays. You're going to want to use something like a list or some kind of collection, and that's a little bit more advanced, because then you'll be able to add something, remove it, which is actually a little more ideal for a deck, since a deck isn't always a fixed size. When you draw cards, when you give them to players, when you burn them, you actually manipulate the deck in ways that it's not always 52 cards, of course. Therefore, you're going to have something a little more robust. But this will start you off in the right direction. And like always, I just feel like it's kind of a good, it's always a nicer refresher to use something that's a little more physical to program with rather than just numbers, something that we can actually relate to, which most of us can relate to some kind of card game. So that always makes it a little more fun. So there you have it, guys. And now in the next video, we'll start on another topic with some other data structures and other methods to use, and then ultimately come back to this and make a little bit more of a robust card system and game that we can actually play with, and then we can deal with shuffling, drawing cards, burning cards, and stuff like that, because we can use some kind of data structure that will allow us to do so here in C#. All right. As always, guys, thanks for watching.